Hello everyone, a warm welcome to my another video where I would like to demonstrate the use of RoboDK software with microcomputers and microcontrollers. I hope you enjoyed my previous video where I demonstrated the use of RoboDK software to integrate with a microcontroller, a servo positioner, what we have developed using Arduino and a servo motor. In that I demonstrated you how to model a mechanism and then make a basic Python script and communicate with Arduino using serial communication and to transfer or run this positioner on Arduino using RoboDK. In this video I am stepping one step more ahead to introduce you to use a Raspberry Pi, which is a microcomputer widely used across all platforms, to integrate with RoboDK. Now, the first step of modeling the mechanism remains one and the same. So I already explained you in detail how to model a mechanism in my previous video. I'm also giving a link to that video, so if you haven't watched that video, please do watch the first session, especially the first 10 minutes of that video where I'm demonstrating the method to create a mechanism using RoboDK. And after watching the 10 minutes, please do continue from this video where I would like to demonstrate to you how to integrate with a Raspberry Pi microcomputer. Now you can see my screen. Here is the same positioner which I demonstrated in my previous video. Everything remains same. We do have one axis, which is the G1 axis, and this can go from 0 to 190 degree. As I told you in my previous video also, please do adjust the direction of movement after checking with the direction of your servo motor on your actual mechanism you created. Now I would like to also show you the mechanism I created, and then we can actually switch back to explaining the code. So you can see on my screen we do have a Raspberry Pi, and this is connected to the servo mechanism what I designed and what I showcased to you in my previous video. And this is connected to the servo motor, which is controlling the servo positioner. So the hardware is pretty the same, but the major difference what we have brought in is, instead of an Arduino on the previous case, we brought in a Raspberry Pi, which can give you a lot more options to work with. Now, if you ask me a question, why can't you install the RoboDK directly on Raspberry Pi? I did try many times on different versions of Raspberry Pi, Raspbian OS, as well as the RoboDK versions, but I was unsuccessful in getting the RoboDK working on a Raspberry Pi platform. This might be an issue with the dependencies. What do I have? What I failed like many times was maybe one of the dependency is the Qt, but I think there are more other dependencies also might be causing this issue. So I was unsuccessful in trying or getting the RoboDK on a Raspberry Pi platform. Another major reason I would always suggest you to run the RoboDK is not on a Raspberry Pi is because I will always suggest have the hardware connected to the microcomputer, which will give you more space and more easiness in handling. And as RoboDK is a kind of a simulation software, you can always run it in a host machine and then try to communicate with the hardware or the robot what you built on a microcomputer or a microcontroller. So let me take you to the code now as next, and then explain you how this can be done in a set of sequence of operations, and that can easily guide. So as you know that we do have RoboDK software, and as demonstrated in previous video too, I have modeled the mechanism, and the mechanism is ready over here to get integrated with the actual hardware model what we created. And I do have a Python program, so which is created over here, which will communicate. So now let me explain you the steps what is key in executing this. So the first thing is, we know that generally we do have the connect option, and we do connect with a robot using this method. But in our case, it's a Raspberry Pi. So if you actually try to create during more options and a driver, which will initiate this protocol of TCP/IP and get it communicated, that will be a wonderful experience. But what I'm showing you is a very basic in having a simple Python script inside your work cell itself, and which will actually does the operation of executing the TCP/IP communication with your hardware. So for the purpose of easy explanation, I would like to use the PyCharm IDE. So in this step, we do have three things. One is the RoboDK software, which is running on a host machine. The second one is the Raspberry Pi. And the third thing is the mechanism or the kind of robot which actually you built, and that needs to be controlled using this microcomputer, which is Raspberry Pi in our case. So of course, I'm using the GPIO pins of Raspberry Pi in controlling this mechanism, but you can also use any other methods which you are comfortable with. But one of the easiest one is to use the GPIO pin. So I'm just showing you the code which is running on Raspberry Pi first, and then we will get back to the to the client machine, which is the RoboDK PC. So in this code which I'm using on Raspberry Pi, I'm treating Raspberry Pi as a server. So I have created a few basic things to receive the socket or TCP/IP communication from the RoboDK. So the initial lines you see over here, I'm using, of course, a socket library and then time library to get some delays, and then I'm using the GPIO 00, and I'm using a wonderful library called Angular Servo. So I think there are some videos on the YouTube which you can find using an Angular Servo method. And of course, GPIO 0.pins in PyGPO factory is another kind of library which I'm making use. But the one thing I noticed using many of the libraries which is actually working for many of the people on the YouTube, what I watched was the motion what you get with the servo is not very comfortable. It has a jerky motions. So on Raspberry Pi 4, which is the version I'm using, and I'm using the latest Raspbian OS from the Raspberry Pi. So in this condition, I wasn't able to get a good movement on the servo. So I will try to do a detailed video how did I get that, but please note down that in order to execute, to get a very good movement using the GPIO 0 library on your Raspberry Pi, you need to have all these libraries make use in your program, and please do execute the sudo pigpiod command in your terminal before executing this code what I am showing you right in front of your screen. Otherwise your code will not work. So please do, I put a comment to here, so please do execute this in a terminal in Raspberry Pi before executing this code, otherwise you are going to get angry. So then I'm just basically defining the angles wherein I have to travel or make the servo move. And then this is the lines where I'm trying to communicate with my client machine. So I'm using a port of 65432, and I'm just trying to create a socket and binding it with the message. And here I'm going to print for the RoboDK connection. So once you have this code running on your Raspberry Pi, this will keep waiting for a connection to be established from your client machine. So we can see then while executing this, and then once the connection is established, I'm receiving and I'm printing from where did I establish the communication. And then the most important thing is I'm trying to receive the command which is making my servo to move. So of course you know that we have defined a function which is set angle for our servo to move, and we need to have an basic information of the angle, which is an argument which is expected in this function. So we are trying to get that in. So I'm trying to decode the code what I've used received in the socket message, and then print that command what I received. And of course that command I'm trying to convert it to an integer because that is what the angle function is expecting. And then I am setting my servo using the set angle function which I described above, which is this function set angle. I'm trying to move my servo to the assigned position, and then it's basically the closing of socket command. So that is pretty much on the server side, which is the Raspberry Pi. So this command, this code, whatever you see over here, this needs to be executed inside your Raspberry Pi. Okay, so just making it clear, this needs to be executed. The server code needs to be executed in your Raspberry Pi. I'm just showing you this on my host machine for the convenience of explaining it on the PyCharm. Now, getting back to the second step where you need to set up your host machine or the machine you are running the RoboDK. So in this, we do execute this code, which is the client code. So here of course we are using the socket messaging, so we are using that library, and then we need to communicate with the RoboDK because we are running RoboDK in this specific machine. And I'm specifying the address of my host machine. So this one has to be the machine, the IP address of your Raspberry Pi. So make sure that your Raspberry Pi is on the same local network as your host machine is located. So please do check for the IP address from your Raspberry Pi and do enter that, and make sure your port what you used on your client machine is matching with this port what you mentioned. Then this is pretty much same. Of course, all of you watch my video how to establish communication with RoboDK. So everything remains same. So here again it's different because the previous video I used Pi serial communication, but here we're using the socket message, so we do have to define the socket settings. So that's a basic command to define a socket messaging. And here I am defining the name of my robot, which is associated with the RoboDK. So please make sure that in your RoboDK, so of course you know how this is my RoboDK robot. So you know it's servo positioner. So this is matching with the servo positioner item on your RoboDK. Now I'm defining a basic function which is called a servo joint move, where it has two arguments, the joint number and the joint target. So you need to, in our case, we do have only one joint, which is joint 1 or joint 0 ideally, start from 0. And then if you have multiple joints, of course, you can specify using that. I'll try to create another video where we have multiple access controls, but in this video, we do have only one joint which is assigned as joint 0 and the target associated with that. And again, the code remains all the same what we used in my previous video. There is no change at all. It is the basic, or the only change what I brought it in is just associating it with the socket messaging, the TCP/IP method, instead of the Pi serial method what I used on my previous video. So here you can see here the servo anchor is equal to the join number, which I'm calling from the list of join using the RoboDK command, and then I'm sending the socket send all string servo underscore anchor using the socket method. So that's pretty much the function. And here is where I'm calling my function. So I'm executing three movements, which is servo join move. Joint number is 0 and target is 90. Then I'm going to I'm giving it a small delay. Then going to the next command, which is servo join move. I am executing the joint 0 to 170 and then back to joint 0 back to 0 degrees. Now I'm of course receiving a response once I transfer this to Raspberry Pi or my Pi robot, you can call it as, and then pretty much closing a small delay and closing the communication. So that is very much on the code. So we do have a client code, a server code. The client code is running on the host machine where this is my host machine, so which is running the RoboDK. I do have the Raspberry Pi which is connected on the same local network, which is executing the Pi robot server code. So this Pi server code runs on the Raspberry Pi, and this client code runs on my host machine. So that is pretty much on the setting. Now, the next step is on the RoboDK side. If you notice, I do have the same code which I just explained to you. I do have same code. You can also directly execute it from the PyCharm environment, but just to show you that this without a PyCharm, you can directly have this code inside the RoboDK library, RoboDK cell, and then you can directly execute it from the RoboDK. So the next step is where I'm going to demonstrate you the complete scenario of executing this code on my host machine, and my Raspberry Pi robot will receive this and try to move the servo positioner according to the command I'm giving from the RoboDK, and together with the RoboDK simulation getting executed on the host machine. So you can see my screen now. I do have the RoboDK software on my host machine, and you can also see on my right hand side the screen of Raspberry Pi. So we do have the server code on the Raspberry Pi. So the same code I just explained to you, uh, and that the same code what we are running on the Raspberry Pi 2. So that's the code here, and we do have the Raspberry Pi. You can see my RoboDK mechanism is exactly matching with the mechanism what I built on Raspberry Pi 2. So the first thing is I'm executing my server command on the Raspberry Pi. So I'm just executing that. So you can see here now it's waiting for the RoboDK to connect. So now I haven't executed the command yet on the RoboDK. So now it's the robot, the Raspberry Pi robot is waiting for the RoboDK to establish the communication. Now on my RoboDK side, I'm using the same Python script which I explained you on the PyCharm. So I'm running it. You can see here the connection is established, move to 0 degree. You can see on the hardware 2. Now it's going to 170 degree. You can see the commands being populated on the terminal. Yes, back to 0 degree. So I'm trying to run it once more, and you can see here now the process has finished with the exit code 0, because this has the socket is ideally cut from the host machine, so the code is end. Now I will run it once again for your easy understanding. So I'm just running the same code, which is the PyRobot server code, and is waiting for the RoboDK to connect. Now I haven't started my code yet on the RoboDK side, so I'm running my Python script. You can see here at established connection, move to 90 degree, the hardware to move to 90 degree, 170 degree the hardware. You can see the RoboDK also has moved to 100 degree, back to 0. The hardware too has gone back to 0 degree. So that's a wonderful demonstration how to use a RoboDK software with a Raspberry Pi.